Hi, welcome to the Deep Learning ICP 5. This ICP is about sentimental analysis using LSTM network. The goal of this ICP is to get a basic understanding of the working of LSTM and also the different types of R and to perform the sentimental analysis for the given code. So for this, the softwares that I used is like Python 3.7 as well as Jupyter Notebook. So the first question that they have given is like save the model and then use the model to predict on the new text data, and they have given us some specific text. So for that, initially this is the point where we have loaded the sentiment.csv, and we read the columns necessary, that is text as well as the sentiment. These are the two columns that are necessary for this analysis. And then we have normalized the data by making all the characters in the text to the lower case, as you can see here, and eliminate all the special characters. This is the point that we are eliminating the special characters besides the alphabets and the digits, and then uh, we have replaced the we have replaced the positive we have replaced the retweets with null, so we don't want the retweets over here, so we have replaced it with null. Then we have applied the tokenization of taking the max features around as 2000 and followed by fitting it on the normalized data and then converting it to sequence, and then applying some padding on it. So here is this like how we have applied the padding over here. um, so in the later part of it, like next we have created a sequential model where we have embedded the layer of 128 neutrons over here, and with the input length as total number of features, the LSTM layer with around 196 neurons, and the dropout is um, and then next, like in the model, coming to the model, we have added the embedding layer, here we have applied the max features. It's going to be like 128 neurons, and then the LSTM layer with the neurons as 196 as well. um, and here dropout and the recurrent dropout are set as 20% over here, and the output um, okay, here basically the output layer has three things. J neurons, as we are using three labels, that is positive, negative, and neutral over here. And we are using the softmax activation function over here. And for the loss, we are using the categorical cross entropy, and um, as there are more than two classes over here, we are using this. And next, to convert the data to numerical, we are calling the label encoding class over here. And we are passing it to the cat it to this two categorical function whose output is one hot encoding over here. Mm, and then we are trying to fit we are trying to sample the data and fit and save the data. So here over here we are trying to fit the data. mm, so we are using the epochs as 5 over here, and later we are calculating the accuracy of the model over here, as well as the score as well as the accuracy over here. And then finally, what we are doing over here is we are saving the model to the disk, like the model that we have over here, we are saving it on the name of model.hy over here, and we are reading the data from this model, and we are saving it to the JSON file over here. And that loaded JSON we are saving under the loaded model JSON, and after loading we are closing the JSON file, and then we are loading it to a model and then that loaded model is like we are loading it to a new model, that is loaded model, and then we are going to analyze the new the tweet data that is over here with the help of this loaded model. So the tweet that they have given is the tweet that is present over here, and first after tokenizing it and after padding we are identifying here it's an output like where we are going to compare the data with the data that is present in the model, and if there's a match we'll get a value, otherwise it will be zero. And after doing that we are going to predict the street data with the help of the loaded model over here. So after performing the sentimental analysis, the values that we could see here, where this is the negative value and this is the neutral value and this is the positive value, which indicates that this tweet is perfectly a positive tweet according to this model, since the value of the positive data is very high. So the resulting output we get is positive. So here we could see it's 0.85, which is greater than the others. So this is the end of the question number one. So coming to the question number two. So it's almost the same, but then we are applying the grid search CV on the source code that is provided in the class for the second question. So here also we are reading the same data and we are converting into the lower letters and then lowercase, and then we are taking uh, only the necessary formats that are required, that as I told, like lowercase letters of A to Z, uppercase, and then 0 to 9. Basically here we are removing out the special characters, and then again we are like doing the same thing, that is replacing the repeat with null and then applying tokenize and padding, and then creating a model over here and again level encoding, and then so the parameters here are we are using over here. Um, over here are the new parameters that we are using over here are the um, mm, as you can see here, it's like a batch size as well as the epochs of the param grid. Like basically what this grid search CV is like, it's generally auto-tunes the hyperparameters and gives the result which result of which combination of hyperparameters has given the best accuracy. So for performing this classification we are using the Keras classifier, and we pass that model as a parameter for this grid search CV. So this model that we have created, we are passing it as a parameter to the grid search CV, and we have taken two parameters, that is batch size and the epochs. And as you can see here, we have taken this batch size and epochs over here. So basically, here we are doing this hyperparameter optimization, and so we have found that this using this epochs 2 will be the best for the usage of this um, from this we have identified that this is the best one, and the value of it is 0.677822. So next one is coming to the question 3. Here in this question 3 we are using the span dataset, like span CSV, where again we are converting this data to lower letters and then removing the special characters, and then trying to set the maximum features, tokenizing it, padding, and then creating the model with the same things, and then we are imprinting the model summary over here, and then label encoding the same thing, and we are setting the batch size, and then we are creating a model, and here we are going to create the history object from this model and saving the data to a new model called scratch.h5, and we have set the epochs as 5 over here also, and then we are calculating the metrics of loss and accuracy over here. And here we have found that this model is accurate with 0.98%, and the loss is just 0.09%. And for the bonus question purpose, what we are doing is we are going to plot on the history object with both loss and accuracy parameters, and the accuracy with accuracy and loss taken over y-axis, and then epochs taken over x-axis, and then the plots are as follows. This is the plot for accuracy as well as this is the plot for model, and here what we have identified from this is this model as higher accurate percentage when compared to loss. Thank you.